Welcome and thank you for joining me today. In this lesson, we'll explore polynomial division. By the end of this lesson, you'll be able to divide a polynomial expression by another polynomial of lower degree using either long or synthetic divisions. Before we begin dividing polynomials, let's review the process using numerical long division. Consider the example 144 divided by 2, or as you can write them in fraction form, 144 over 2. We set up the division by writing the number that is being divided, that is 144. And then we're going to write a bracket here, and on the side or inside the brackets, we're going to write the number that we are dividing by, or the denominator, so the number 2. Next, we're going to draw a horizontal line, and right here is where we are going to write the answer. Now, we begin the division by checking how many times 2 goes into the first digit of the number that we are dividing. 2 doesn't fit into 1 because it's larger than 1, so what we're going to do is look into the first 2 digits. 2 goes into 14 7 times, so we're going to write number 7 right here. And now we multiply 7 by 2. 7 times 2 is 14, and then we'll subtract 14. 14 minus 14 equals 0, and it's time we bring down number 4, which is the next digit in the number we are dividing. Then we repeat the process again. 2 goes into 4 2 times, so we're going to write number 2 here in the answer. And we multiply 2 by 2, which equals 4. And we subtract again. And we see that 4 minus 4 is 0. So if we were to continue the process, we would bring down another digit, but as you can see, we have ran out of digits, which means that we stop the division right here. And this number at the very end in the division is what we call the remainder. In this case, it's equal to 0, but that's not always the case. Now, looking at this division, we have to identify a couple of items. So first of all, the quotient or the answer is 72. The denominator, we call this a divisor as well, but we'll talk about it later, is equal to positive 2. The numerator is the number that we are dividing, is 144, and the remainder is equal to 0. If we were to write the number that we divided by its denominator and the answer or the quotient and the remainder, then you would say that 144 is equal to the product of 2 with 72, and obviously we would have to include the remainder in it as well, so plus 0. But when adding a 0 to a number, the value of it doesn't change, so we may as well not write it at all. As you can see, we have written number 144 as a product of 2 numbers, which makes these 2 numbers factors of 144. So we're going to say that since the remainder is equal to 0, imagine if the remainder wasn't 0, then we cannot make the statement that these are factors. But when the remainder is equal to 0, then both the divisor and the quotient are factors of the number we are dividing. So next we're going to look at another example, very similar to what we just did. This time we have 145 divided by 2. So we are setting up the division the exact same way. I'm going to say 2 goes into 14 7 times. 7 times 2 is 14. We'll subtract this number. And we have 14 minus 14, 0. We'll bring down number 5. 2 goes into 5 2 times. 2 times 2 is 4. We'll subtract 4, and 5 minus 4 equals 1. So 2 doesn't go into 1, so this is where we stop the division. So in this case, the quotient is 72, just like in the previous example. The denominator, or the number we divided by, is 2. The numerator is 145 this time, and the remainder is equal to 1. So if we were to write the numerator in terms of quotient and denominator and the remainder, then we'll say that number 145 is equal to the denominator of 2 multiplied by the quotient, or the answer 72. Remember, 2 times 72 is 144. And then we will have to add the remainder of 1. And again, this reinforces the idea that when the remainder is equal to 0, 2 and 72, so divisor and quotient are factors of the number that is being divided. But when the remainder is different than 0, we cannot say that 2 and 72 are factors, because 145 won't divide evenly into 2 and won't divide evenly into 72. Now, the reason why we went over this long division using numerical examples is because polynomial division in principles would work in a similar way. But first, let's clarify some terminology that is about to change here. So in polynomial division, the numerator is called the dividend. We usually call this px or f of x. The denominator is called the divisor. And for this, we use the symbol dx. The answer is called the quotient. And the symbol used for it is qx, you guessed it probably. And the remainder is indicated by rx. And if you're wondering why rx, you will see that sometimes the remainders won't be simple constant numbers, but they would be polynomial expressions. Now, this is the division statement. And at first, this sounds and looks a little bit awkward and big, but the way that I like to memorize it is this. So if you have the number 7 and you divide it by 2, the answer will be 3. And you will have a remainder of 1 that hasn't been divided by 2 yet. Another easier way of remembering this is if you had number 7 and you divide it by 2, you would get an answer of 3 and a remainder of 1. So if you divide by 2, the answer will be 3, the remainder will be 1 again. Now, if you divide every term in this statement by 2, then you would get 2 and 2 simplified, and we get the number, or the polynomial in our case, divided by the divisor, dx, equals the answer, or the quotient, plus the remainder, which is the number 1, divided by dx, which is the divisor again. So this is the division statement in polynomial division. And the reason why we mention this is because very often when you're asked to perform the polynomial divisions, you will be asked to write the final division statement, which is important. Now, when dividing two polynomials, it is very important to state the restrictions in the denominator. Remember that from grade 11, right, when we did rational expressions, remember that in polynomial division, we have variables in the denominator, and the denominators cannot equal 0. So we're going to say that in this case, the denominator has just x, so we're going to say x has to be different than 0. This denominator here has to be different than 0, which means that x has to be different than 3. And for this denominator, we have to do a little bit of work here. And we're going to say that's 1 over the factored form of this denominator would be x plus 3, x plus 4. So you will have two factors. If either one becomes 0, makes the denominator 0. And we'll say that x plus 3 has to be different than 0 and x plus 4 different than 0, which will make for two restrictions, x different than -3 and different than -4. Now let's begin with our first example in polynomial division. I've written the steps here on the side. So if you want, you can pause the video and try to follow the steps and perform the division on your own. It is a great learning strategy that builds confidence in your own thinking. Other than that, just follow along and I'll explain this step by step. Step number 1, we will have to arrange the terms in the ascending order, meaning descending order. So meaning that we're going to start with the highest degree term and end with the lowest degree term. In our case, the terms are listed in the correct order. Now, the next thing that we want to make sure is that if you have, say, for example, a third degree polynomial, then you're going to start with a third degree term, and then you'll continue with the second degree term, the first degree term, and the 0 degree term, which is a constant. And if any of these terms were missing, which is not the case here, by the way, you still have to write that term, but with the coefficient 0. Now, we're going to look at such an example a little bit later. Then we're going to write the divisor, which in our case is x minus 3. So let's write that down. I'm going to draw that line in here where we're going to write the answer. Now, we begin by checking to see how many times the first term in the divisor goes into the first term of the dividend. So x goes into 3x cubed how many times? Now, this is a little bit tricky because when it comes to numbers, we can kind of visualize them better. But remember that when we were checking to see how many times number 2 goes into 14, then we said that it goes 7 times because it's kind of intuitive, but another quicker way would be 14 divided by 2 will tell me exactly how many times goes into 14. So if you were, for example, to check how many times number 2 go into 7, then you're going to say, 7 over 2 is going to be equal to 3. So it goes in 3 times. Now we do something exactly, the same as in numerical division in here. So if you want to check and see how many times x goes into 3x cubed, then we take 3x cubed and we divide it by x. 3x cubed divided by x is 3. So this is the coefficient of 1. 3 divided by 1 is 3. And this is x cubed divided by x to the power of 1. X cubed divided by x power 1 is x squared. So what that means is that x goes into 3x cubed 3x squared times. So we'll write 3x squared here. Next, we are multiplying 3x squared with the divisor. So let's check and see what it looks like. So we have 3x squared multiplied by x minus 3. And we'll write the expanded form of it right underneath our polynomial. So remember that we have 3x squared times x, 3x cubed. And then 3x squared times negative 3, negative 9x squared. I'm going to draw a line in here. And we will subtract this expression from the polynomial expression, just like we subtracted the numbers in here from the number before it. So we have 3x cubed minus 3x cubed, that's 0x cubed, negative 5x squared minus negative 9x squared. Remember, when you minus a negative, then you get a positive. So that will make 4x squared positive. Next, we'll bring negative 7x down. And now again, we follow the same process. How many times now does x go into the first term in the polynomial? So we have 4x squared. So how many times does x go into 4x squared? We follow the same strategy. We go 4x squared divided by x. So 4 divided by 1, 4. X squared divided by x to the power 1 is x to the power of 1. So that means 4x times. So we'll write 4x here. Now 4x will be multiplied by x minus 3. Now we expand. 4x times x is 4x squared. And 4x times negative 3 is negative 12x. Going to draw a line in here again, and we will subtract this. Now, keep this inside the brackets because you're subtracting each and every term in here, so you don't have a single term, so we got to be careful. Now, as you can see, we have 4x squared minus positive 4x squared, that's 0x squared. And negative 7x subtract negative 12x is like negative 7x plus 12x. That is 5x. We're going to bring down our next term, which is negative 1. Again, we follow the same process. It's repetitive. So how many times does x go into 5x? So for this, you can simply divide 5x by x. And the answer here will be 5. You see that, oopsie, x is simplified, and we just have the coefficients. So we're going to write in here the number 5. And as always, same process. We're multiplying 5 by the divisor x minus 3, expand it, 5x, and then minus 15. Going to draw the line again. We subtract, keep this inside the brackets. 5x minus 5x is 0x. And negative 1 minus negative 15 is negative 1 plus 15, or positive 15. If you want to check to see how many times x go into 14, I'm going to say it goes no times. So this is where we stop our division. And this is when we say that this leftover number in here will be the remainder in the division. So next we are going to state the final answer. So the final answer is the polynomial 3x cubed minus 5x squared minus 7x minus 1 when divided by x minus 3 will give a quotient of 3x squared plus 4x plus 5 and a leftover or a remainder of 14, which still needs to be divided by x minus 3. And this is the final, or the division statement for this particular division. So this is how long division work in polynomials. Remember that the divisor needs to be of degree lesser than the number that, or expression that we are dividing, or the dividend. I hope you found the instructions useful. We will continue with more examples where we see different facets of polynomial division in the next video. Until then, bye for now, and thank you for learning with me.